This is a demonstration video for the active fleet monitoring and reporting system. Here we have a diagram indicating the flow of data through the system. The system acquires data through an accelerometer and a GPS. The microcontroller processes this data, which then triggers certain events depending on acceleration, speed and angle of tilt severities. The microcontroller periodically stores relevant data on a mass storage device, which acts as a black box. Information is also sent through a GPRS modem, through GSM networks and stored on a database on a web server. The device also has multiple LEDs to indicate GPS, modem and secondary storage status. When a device is installed into a vehicle, in terms of this project, it is called an asset. Multiple assets, or a fleet, report and can be monitored from a single web interface. Other than tracking a vehicle's position and velocity, one of this project's main objectives were to characterize and determine reckless driving behavior. Numerous control tests were conveyed in order to characterize the normal and tangent components of a vehicle's acceleration. Thresholds were derived for the different vector components, which when exceeded triggers events that shows on the web server for the specific asset. This is a test to characterize tangent acceleration for a comfortable stop. These small peaks indicates the gear shifts while accelerating, whereas the last peak indicates the deceleration to the complete stop. This is a test to characterize tangent acceleration for an uncomfortable stop. Here we can see the vehicle stopped accelerating once it reached 60 km per hour, and then stopped in a shorter time, thus experiencing more acceleration. All the normal acceleration tests were done by completing a circle, the first in a comfortable and the second in an uncomfortable manner. Once again, we can see the tangent acceleration on the y-axis. Here on the x-axis, we can identify the normal accelerations while completing the circle. The first small peak is the entrance of the circle by turning left. The long peak is the continuous acceleration experienced while turning right, and lastly, exiting the circle with a left turn. Here the peaks on the x-axis is much larger, indicating higher normal acceleration. This is the dashboard the end user will be interacting with. The state of the asset is indicated here. The light is blue when the vehicle is stationary and green when active. The GPS fixed type is described here, whether 3-dimensional, 2-dimensional or none. This bar indicates the amount of satellites being tracked. These orange markers indicates the ideal range for a dependable GPS fix. Here is a speedometer reporting the latest recorded speed. Next to that we have the speed history graph. This can be scaled to indicate a specific time span. This blue band indicates the regions that triggers certain behavioral events. Below this we have a compass indicating the latest recorded cardinal direction. Next to this we have a behavioral history graph. This indicates a level 1, 2, 3 or 4 event with a timestamp. This graph can also be scaled to view a specific time. Here we have a Google Maps gadget indicating the previous and current recorded position coordinates.